Hello, in this video we're going to look at evaluating the composition of trigonometric and inverse trigonometric functions using right triangles. So let me just show you what that looks like. Something like that, a problem like that. And so what you'll find is the recognition for this is you have two different trig functions. They're not the same. With cancellation, the trig functions were the same, so they undid each other, the inverse and the right and the function. But here you have two different, you have the composition of two functions and they are not the same. All right. So here's just one general method. I like to define the inverse trigonometric function of the number that's given as the angle, because remember, for a regular trig function, I call it regular, in comes an angle, out comes a number, which is a ratio of two sides of the right triangle. So with the inverse trig function, in comes a number and out comes an angle. So I'm basically just saying, look, I'm going to call it the angle, an angle, whatever that answer is. Then I'm going to take the trigonometric function of both sides of what I wrote down in 1. That'll allow me to see what kind of ratio I'm dealing with and set up a right triangle. Right? And then I can use Pythagorean theorem to find the remaining side of that right triangle. Then I'll rewrite this question that was in part 1, and then I can use this triangle, the right triangle, to actually find the trig ratio that they're asking me for. So let's take a look at that. So evaluate this. Step 1. Here's my inverse trig function. So for 1, I'm going to say let theta equal this, cotangent inverse of 1/7. Okay. Now I'm going to go ahead and take the trigonometric function. So I'm going to take the cotangent of both sides. And this is not multiplication. I'm actually taking the trig function of both sides. So it would be like squaring or something like that. You square both sides. That's actually you're performing like that. This is not just multiplication. I'm not multiplying by the function. All right, so what this allows me to do is, oh, and by the way, of course, you would always check to see if this input was valid, but for cotangent and tangent, every number is valid, so it doesn't matter. So these cancel out, and I now have cotangent of the angle I'm looking for is 1/7. Right? So now this allows me to set up a right triangle. Okay. Since I know cotangent is defined as x over y, I can now say, okay, I'm going to set up a right triangle. Now, because I'm dealing with these inverse trig functions, I still have to be careful about these range intervals. So cotangent can only be, the inverse cotangent can only be in quadrant 1 or 2. So I can only draw my right triangle in quadrant 1 or 2. Now in quadrant 2, you have one motion that's negative and one that's positive, so your ratio would be negative. Since my ratio is positive, I know I have to be in quadrant 1. So I know to draw my triangle in quadrant 1, right, like this. So here's some angle theta. And I know the x is 1 and the y is 7. So now I can use the Pythagorean theorem. X squared plus y squared equals r squared. So 1 squared plus 7 squared is r squared. So you have 1 plus 49. And so you're taking the square root of 50. Now normally this would be plus or minus, but I know that r is positive. It's the radius, so it's going to be positive. So I have r is square root of 50. Okay. Now I come back and I say, well, you know, let me rewrite this. Since they gave me the cosecant of the cotangent inverse of 1/7, and I let cotangent inverse of 1/7 be theta, right? Then I'm going to say that all of this is actually theta right here. Okay. So now I'm going to rewrite this in part 4 to say what I'm really looking for then is cosecant of theta. That's really what I'm looking for. And now I can actually find the cosecant of theta given this right triangle. I know cosecant is defined as r over y. So r is square root of 50. Y is 7. And that is my answer. Okay. All right, let's take a look at another one. And you might want to pause the video and go ahead and try this. See what you get. Okay. So step 1, I'm going to let theta be inverse cosecant of -5/2. Okay. Step 2, I'm going to take the cosecant of both sides. oops, I forgot to write the cosecant in here. Let me just rewrite that. Oop. Boy. All right, there's my -5 halves. Okay. Now, these cancel out. I'm left with cosecant of theta is -5 halves, right? So now I can say, okay, I'm going to set up a right triangle. And I know for cosecant, let's see, right here, I can be in quadrant 1 or 4. Since this is negative, a negative ratio, it must be in quadrant 4. Okay, so I know to draw my triangle in quadrant 4. Here's theta. Of course, you could use any angle, by the way. I use theta a lot. But so cosecant is r over y. And obviously one of these is negative, but it's not the r. So here, r is 5, and y must be the -2. So then I got to find x. So I'm going to say, well, x squared plus y squared is r squared. So x squared plus -2 squared must be 5 squared. So x squared plus 4 is 25. Subtract 4 from both sides. X squared is 21. Take the square root of both sides. X is plus or minus square root of 21. And we're in quadrant 4, x is positive. So x is square root of 21. Okay. Now, what I was originally trying to find here, since I let theta be all of this, right? I'm really finding tangent of theta. So I want to find tangent of theta, which is y over x. And now I can say, oh, well, that's going to be -2 over square root 21. And that's my answer. Okay. So here's our last example. Now, of course, you always do a mental check for input. Is the input valid? And we know for secant, for inverse secant, -1/2 is not possible. So technically, you should already just go, boop, done. However, let's say you forgot, and you started to set it up, and you said, oh, okay, let theta equal, secant, inverse secant of -1/2, okay, and then take the secant of both sides, so secant, boy, is just -1/2. Here at this point, it should be kind of obvious. You'd be like, wait a second, there is no angle for which secant of that angle is -1/2. But let's say you don't even see it there. So you say, okay, I'm going to start setting up a right triangle. Secant here has to be this quadrant because it's a negative ratio. Right, so I know it's in quadrant 2. And you say, well, okay, this is r over x, right? R over x, and I'm going to put this in quadrant 2. So r is 1, x must be -2, and I'm going to find y, so you say x squared plus y squared equals r squared. So -2 squared plus y squared equals 1 squared. 4 plus y squared equals 1. So here you have y squared equals -3. Now at this point you definitely should be able to tell, I can't take, the square root of that. That's not going to work. It's in the reals, right? So then I know, oh yeah, no solution. Okay? Thanks so much for listening.